G'day there and welcome once again to Oz Navigation. Today I'm going to have a talk about horizontal sextant angles. You might go, what's that and why do I care? Well, you probably don't care, and that's fine. We'll see you later. But a horizontal sextant angle uses a sextant, which I'll talk about in a moment, to determine the angle between two objects along a horizontal plane. In the example that you can see here, the angle between these lighthouses is 32 degrees. Now from that angle we can use some mathematics, or we can use a lookup table to determine the range of positions that we could be on that would form that angle of 32 degrees between those lighthouses. And that line, or that curve of positions, is known as a position line, and it's a position line created from a horizontal sextant angle. So this is a sextant. A sextant is a device that is used to measure angles. So the scale that you can see down the bottom here are the various angles that you can measure, and that looks like it's about 0 there, and I think it's about 120 or 150 degrees there. The angle is measured by looking through this eyepiece, and what happens is the light comes in here. Some of the light goes directly into the eyepiece, and the rest of the light reflects off these two mirrors and comes into the eyepiece. And so what it does is it allows the light that's coming in reflected off the two mirrors to be adjusted by this angle. The effect of doing this is that it brings the two objects together, and it shows them as a single object when you look through the eyepiece. Once you look through the eyepiece and you have the two objects together, you can measure off the angle and read the angle between them. In a previous video I did on vertical sextant angle, which I'll link in down below, we used the sextant and we took this lighthouse and we superimposed it on the horizon here to get the vertical angle between the horizon and that lighthouse. And when we look through the sextant eyepiece, it looks something like this, with the lighthouse superimposed over the horizon. When it's in that position, we can measure the angle between the two. We could do our vertical sextant angle. In this case, we're turning the sextant on its side, and we're doing precisely the same thing. So to do a horizontal sextant angle, we need to start with some objects that are on your chart and that you can see from the ocean. Let's say you think you're somewhere out here in the ocean. You don't know where you are, but you think you're out here somewhere. You can see the three lighthouses off on the coast here, but you're not quite sure where you are. So if we take our sextant, we can measure some angles. We can say that the lighthouse 1 to lighthouse 2 angle is about 35 degrees, and the angle between lighthouse 2 and lighthouse 3 is about 42 degrees. I've drawn them in here on the chart here, but it really could be anywhere because we're somewhere in this grey circle, we think, but we don't know where we are. I've just drawn them in here for demonstration purposes. What we need to do is we need to draw a line between lighthouse 1 and lighthouse 2. And a line between lighthouse 2 and lighthouse 3. And then what we do is we need to do some mathematics. It's only very simple mathematics. If we start with the first lighthouse and the second lighthouse, we know the angle we have between them is 35 degrees. If we subtract 35 degrees from 90 degrees, we end up with 55 degrees. That 55 degrees we can plot as an angle from this baseline from L1 and L2, and that will give us a position out here. I'll draw that in to show you what I mean. So if you draw this 55 degrees from the baseline out in this direction and from the baseline out in this direction, you'll get an intersecting point out here. Knowing this point here, you can actually now draw an arc of positions for this 35 degrees. So using this point as a center point and using your compass to draw a circle, you end up with an arc that looks like this. So it's a circle that is centered on this point, and it travels through both lighthouse 1 and lighthouse 2 and comes out in this direction. Now this line represents all of the positions that could have an angle of 35 degrees to lighthouse 1 and lighthouse 2. If we now look at the second lighthouse and the third lighthouse, we get an angle of 42 degrees. If we do the same calculation, we say 90 degrees minus 42 degrees is 48 degrees. So if we draw in the 48 degrees here and the 48 degrees there, from that point we draw a circle going through L2 and L3 like this. And where this line intersects is our actual position. So that is the position where we're getting both 45 degrees between L2 and L3, and we're getting 35 degrees between L2 and L1. So that is actually a fix of our position. You could tidy this fix up even further and get another reference like a bearing. Say you have a bearing of 300 degrees to L2, draw that through, and that even more confirms your exact location. So while we thought that we were up in this position here, it turns out that we're actually down here quite a bit further. And we've been able to prove that with our horizontal sextant angles and taking a bearing from one of the lighthouses. And of course you could do this with just a single horizontal sextant angle and multiple bearings. So if you had L1 and L2, you could do a circle for the horizontal sextant angle between L1 and L2, and you could also take compass bearings of them both, and you would still end up in the same position. So now I'm going to show you another way to calculate horizontal sextant angle. So for this one, we're just going to use the L1 and L2 lighthouses with that angle of 35 degrees between them. And the distance between these two lighthouses, known from your chart, is 5 nautical miles. Now I should warn you, here's an Oz navigation warning. This section does contain more complex mathematics. Hang on to your hats. To get a horizontal sextant angle, we use our compass, we get the angle between this L1 lighthouse and L2, and we find that it's 35 degrees. We know the distance between the two lighthouses is 5 nautical miles. We've got that distance from our chart. We can calculate the arc of positions that we are likely to set by using this formula, that the radius of a circle containing all of these positions is 0.5 times the distance between the two lighthouses, in this case 5 nautical miles, divided by the sine of the horizontal sextant angle, in this case 35 degrees. So you put that into your calculator, 0.5 times 5 divided by sine of 35, you come up with an answer of 4.36 nautical miles. Now what that tells you is that is the radius of the circle that will cause this angle to exist. So if we know the radius of this circle, we can use the position of the two lighthouses, because they sit on the circle, to determine where the center of the circle is. And we use our compass to do that. So what we do is we use our compass and we scribe an arc at 4.36 nautical miles. We do it from L1 and we do it from L2, and that gives us an intersection marked with this point here. From there, we can draw a circle that goes through the two lighthouses, and once again, that circle represents all of the positions where you will get a horizontal sextant angle of 35 degrees. Like we said before, it doesn't tell you exactly where you are, but it does tell you the range of positions where you must be. You must be on this line if you're getting an angle of 35 degrees. So that's it for horizontal sextant angles. I hope this tutorial was of interest to you and that you survived the mathematics. If you like this video, then please give it a thumbs up, and that encourages me to make more videos of this sort of thing. If you have any ideas or things that you'd like to see with regard to marine aviation or land-based navigation, then please let me know. I don't claim to be an expert on all this stuff, but I certainly do find an interest in it, and I'm happy to investigate and put together information about any form of navigation interest that you might have. So give it the thumbs up, subscribe, tell your friends, and we will catch you next time. Thanks for watching. Bye-bye.